Now let's talk about mitosis, or the dividing of a cell. Actually, mitosis correctly is the dividing of the nucleus, where the dividing of the cytoplasm is called cytokinesis. So when a cell divides, the nucleus is going to divide by mitosis, and the cytoplasm is going to divide by cytokinesis. Now, before a cell can divide, the DNA has to change its appearance. When we're using DNA in the cell, we call it chromatin, but when the cell goes to divide, we want to get all of that spread, thin out chromatin into one area and organize it, actually spiral it around histone units so that it's more condensed or compact, because we can then double that DNA and divide it more efficiently. So chromosome is a condensed or thick DNA, while chromatin is an expanded or thin version of DNA. And during mitosis, we will see DNA change from chromatin to chromosomes as we divide. So let's go and look at interphase, and we're going to draw a cell in interphase. I'm going to be using colored markers to help emphasize some of the cellular structures. So what happens in interphase? Well, interphase really isn't part of mitosis. Interphase is the phase when the cell is doing what the cell does best. If the cell is a muscle cell, then it's going to be contracting. If it's a cell in the pancreas, maybe it's going to be making insulin. But interphase is when the cell does what it's made to do. But in a certain time of the interphase cycle, the message is sent out that we need to make more of this kind of cell, and so it starts getting ready to go in mitosis. There are two things that happen when a cell gets ready to go into mitosis. First of all, the DNA replicates, because if I'm going to have two cells, I'm going to need two sets of DNA. Also, those centriole pairs that we saw when we labeled the cell, they're also going to double. They're going to replicate as well. So let me draw a nice round cell. I'm going to draw a nucleus. I'm going to draw a dark staining spot inside of my nucleus. And at this point, my DNA is all spread out and thin, so it's going to be chromatin. So I'm representing the chromatin in the DNA material with a purple marker. Then the centrioles, remember we found them at right angles near the nucleus. And so right now, we just have a single pair, but right before we go into mitosis, we're going to duplicate those so that we have two pair of centrioles. So that's what happens in interphase. We're preparing to go into mitosis. So let's go to the first stage of mitosis, which is called prophase. Now, if you'll notice, the prophase box is kind of enlarged, and the reason for that is so much happens in prophase. Several things happen, probably more than any of the other phases. Let's look at some of the things that happen, and then we'll draw them. The first thing that happens is that the nucleolus disappears. Remember, that's the dark staining spot inside the nucleus. Another thing that disappears is the nuclear envelope or membrane. The nuclear envelope disappears. Now, remember that we duplicated the centriole, so those centriole pairs are going to move to opposite poles. So the centrioles move to opposite poles. It's like we have a south and north pole on our cell, and they're going to move opposite each other. As they move, spindle fibers are going to form between the centrioles. Spindles form between them, and around the centrioles you're going to have asters form. This is part of the mitotic apparatus that will help separate the two pair of DNA so we can have two cells. Also, something's going to happen to the DNA. Remember when we drew the interphase, we just did DNA as little dots because we said it was chromatin? Well, the DNA is going to thicken into chromosomes. So our chromatin is going to thicken into chromosomes. So now let's draw that. The reason we have such a big box is because we're going to draw an early prophase and a late prophase. Some books you'll see that late prophase named prometaphase, but other people just say early and late prophase. So that's easier, so that's what we're going to stick with. So what did it say? It said our nucleolus starts to disappear, so I'm going to draw just a little bit of it there, and I'm not going to draw any there. It says that the nuclear envelope starts to disappear, so I'm drawing it just fragmented there, and I'm not going to draw it at all over here. What else does it say? It says that the DNA starts to thicken. So by the time we get to the end of prophase, we have a lot of thick DNA chromosomes, but they're not really organized at all. I just drew 4 pair, but remember in a human you have 23 pair. Another feature that happens in early prophase is that the centrioles start to separate. They go to opposite poles. So by the time we're through with prophase, they're definite poles, the North Pole and the South Pole. And as they separate, spindles form between them. As they separate, spindles form between them. And what did we say formed around them? Little asters. This is all part of the mechanism that's going to help the cell divide into 2 identical cells. So now we've drawn in our asters around our centrioles, and we've drawn in our spindles between our centrioles. So this is early prophase and late prophase. Our cell is getting ready to divide. So prophase is the first phase of mitosis. Let's go to the next phase of mitosis. It's kind of like the middle phase, and it's called metaphase. Metaphase is a lot easier than prophase. Let's go ahead and say what happens. The chromosomes, or they're more properly called sister chromatids, because remember we duplicated them. Sister chromatids are going to line up in the middle or on the equator. So in metaphase, we're in the middle. So let me draw my cell again. I'm going to draw my centrioles at opposite poles. I'm going to put asters around my centrioles. I'm going to put spindle fibers stretching between them. And what happens is that my sister chromatids, or my chromosomes, are going to organize and line up in the middle, or what we would call the equator if we were looking at the Earth. So with the chromosomes or sister chromatids line up in the middle during metaphase. And notice that the center of the chromosomes or sister chromatids are attached to a spindle fiber. So in the next phase, what's going to happen is that the centrioles are like a fishing reel, and we're going to reel in our chromosomes. We're going to separate them into the separate chromosomes, so that we have, or the separate homologous chromosomes, so that we have identical chromosomes in each one of the new cells that will develop. So let's go on into anaphase, where we're going to reel in those sister chromatids to opposite poles. So just like with metaphase, we're going to have a cell that has the centrioles at opposite poles, that has the aster fibers around it, and then you're going to see that it's like we're shortening the fishing line, and we're pulling in our sister chromatids to opposite poles. Remember, we had kind of an X, and now we have just half of the X going to each side. So in anaphase, we can say that the sister chromatids are being pulled away. So chromatids are pulled away to opposite poles in anaphase. And something else that's going to happen, and I didn't do a very good job when I drew it, is that the cytoplasm starts to pinch in a little bit. Remember when we first started talking about this? Mitosis is the division of the nucleus, and what is the division of the cytoplasm? Cytokinesis. So it's actually in late anaphase that cytokinesis begins. So we have that with the little pinching in of our plasma membrane on each side. A cleavage furrow is beginning. So let's go to the last phase of mitosis, which is telophase. And notice there's a very big box for telophase, and that's because there are so many things that happen in telophase. But really, it's not as hard as prophase was, because prophase and telophase are opposites. What happens in prophase unhappens or undoes in telophase. So, let's look at what happened in prophase. In prophase, the nucleolus disappeared. So what's going to happen in telophase? The nucleolus is going to reappear. In prophase, the nuclear envelope disappeared. So what's going to happen in telophase? The nuclear envelope, and I'm going to abbreviate envelope, reappears. And in prophase, the centrioles moved to opposite poles, and so they're still there. But when we moved them to opposite poles, we made spindles and asters that formed around and between them. And so since they formed in prophase, they are going to disappear in telophase. So asters and spindles disappear. And then remember, in prophase, DNA thickened into chromosomes. So the DNA now is going to thin out into chromatin. So we're going to have thin DNA material now, chromatin, thin, so that it's all spread out and we can use it. And remember, in anaphase, we started cytokinesis. Well, cytokinesis will be complete in telophase, and what we end up with is 2 daughter cells. So in telophase, we get 2 daughter cells. So let me go ahead and draw it so that you can draw it. Remember that at any time you can pause this video to get your drawings complete and then restart it. So I have early telophase and late telophase. Just like with prophase, there's so much going on, we need beginning and end. So let me draw in the centrioles that have moved to opposite poles. Centrioles that move to opposite poles. Remember that we had spindles, but our spindles are going to start disappearing. So by the end of late telophase, we don't have them anymore. Our DNA material has been pulled to opposite poles. And what's going to happen, our nucleus is going to start reforming. So we're going to have a nuclear envelope starting around there, and our nucleolus is going to form. So by the time we finish late telophase, we're back to a complete nucleus with 2 nucleoli and chromatin. All the centrioles have disappeared, all the asters have disappeared, and now we have 2 identical cells. I'm going to zoom in, and you might be able to see it a little bit clearer. If I can get this where it's supposed to be. Having difficulty. Hang on. Okay, so this would be early telophase. The nuclear envelope is coming back. The chromosomes are starting to thin out to chromatin. You have a few spindle fibers, a little bit of asters left, but by the time you get to late telophase, notice that all of the asters and spindles, all that I had orange is gone. The nuclear envelope is back. The nucleolus is back. The chromatin is thinned out into, or chromosomes have thinned out into chromatin. No asters or spindles. We have 2 cells that are identical to the cell we began with. That is mitosis.